All right, this is the third video for the exam review. For numbers 21, 22, and 23, we want to find the discriminant of each quadratic equation and state the number and the types of solutions. Remembering that if our quadratic equation is in this form, ax squared plus bx plus c equals 0, the discriminant is what's inside the radical, b squared minus 4ac. You might have different variables besides x, like in this case it's r or p, but there's the quadratic term, the linear term, and the constant. This is all true when it's set equal to 0. A mistake a lot of people make is just taking this without setting it equal to 0, or sorry, the equation equal to 0. R squared plus 6r plus 9 equals 0. A equals 1. B equals 6. C equals 9. This is going to look like 6 squared minus 4 times 1 times 9 to get 36 minus 36. So my discriminant is equal to 0. So I'll have one real solution. For this next one, same idea. I need to subtract 8 on both sides. I get 10p squared plus 8p plus 7 is equal to 0. So this would look like a equals 10, b equals 8, c equals 7, 8 squared minus 4 times 10 times 7. So 4 times 10 is 40. 40 times 7 is going to be 280. And 8 squared is 64. So 64 minus 280 is going to be negative 260. So if I have a negative number for my discriminant here, I'm going to have two imaginary solutions. You could also think of this as no real solution. Sorry about the dog's barking. And the last one here, I'm going to subtract 9 on both sides. 8n squared plus 2n minus 3 equals 0. A is equal to 8, b is equal to 2, c is equal to negative 3. Sorry, not 8 squared, it'll be 2 squared minus 4 times 8 times a negative 3. The fact that this is negative tells me that I'm going to end up adding whatever this number is equal to after I multiply. So this is going to be a positive discriminant. 4 times 8 is going to be 32. 32 times 3 is going to be 96. So I get 100. And again, it doesn't matter if it's 111.1. If it's a positive number, then we have two real solutions. All right, so that was all of the first part of our review. I didn't have this last class, but I posted it online, and I also put it in the announcements. There's going to be one more section of it where I've got 3 extra questions. The first one is just solving quadratics by factoring. We've got the quadratic equation equal to 0. This is something that the state or the community colleges are looking to see that people can do. I'll have x, and if it's two numbers that multiply to negative 15 that have a sum of negative 2, so I know there has to be a positive and a negative here. And because their sum is negative, I would need the larger number to be negative and the smaller number to be positive. So x plus 3 times x minus 5. Two numbers that multiply to negative 15, and negative 5 plus 3 is equal to negative 2. The next step is to set each factor equal to 0. So x plus 3 equals 0 over x minus 5 equals 0. So I get x equals negative 3. I would solve that by subtracting. I can add 5 on both sides to get x equals 5. And number 2, this is coming from the section we had in chapter 7, where you have equations with radicals. We're going to square both sides of the equation. So this looks like x squared equals negative 54 plus 15, sorry, not 16, 15x. So you have an option here. You could set this up. We could use the completing the square. We could try this by factoring. We could use the quadratic formula. It's a good idea to set this equation equal to 0. And generally speaking, I would want to take away 15x, add 54. Sorry. Generally speaking, I would want to set these equations equal to 0. I think if you can factor, that's an easier setup, and if you can't, it's easier to have it already to go with the quadratic formula. So at this point, I'm looking for two numbers that multiply to 54 that have a sum of negative 15. The fact that this is positive, like a plus 54, tells me that this is going to be x minus and x minus that I'm subtracting. That we could think of the two numbers of it as negative. It's going to be 9 and 6. So just like last time, I would set x minus 9 equal to 0, x minus 6 equal to 0. Add 9 to get x equals 9, or add 6 on both sides to get x equals 6. All right, so again, when we're solving with a radical, they want us to go through and then check the solutions. So is 6 equal to the square root of negative 54 plus 15 times 6? So 15 times 4 is 60. 15 times 6 is going to be 90. Is 6 equal to the square root of negative 54 plus 90, or 90 take away 54? 90 take away 50 would be 40. If it's 54, this is 6 equals the square root of 36. So I get 6 equals 6. For 9, if I get 9 equals the square root of negative 54 plus 15 times 9. 15 times 10 would be 150 if I take away 15. Taking away 10 would be 140, then taking away 5 would be 135. So I've got 9 equals the square root of negative 54 plus 135. If it was 135 minus 55, that would be 80. If it's 135 minus 54, this is 81. So 9 equals 9. So both our solutions work. All right, for this last one here, I've got 3 divided by 3p plus p minus 4 divided by p minus 5 is equal to 6 over p minus 5. In the same way that we can work with fractions and then multiply by the least common denominator to not have to be dealing with fractions, we can do the same thing here. My least common denominator is going to have a factor of p plus 3 and p minus 5. So when I rewrite this like 3 divided by p plus 3 plus p minus 4 over p minus 5 equals 6 over p minus 5. I'm going to multiply both the left side and the right side of the equation by p plus 3 times p minus 5. P plus 3 times p minus 5. So when it's p plus 3, and you don't necessarily need to show this step, but I think it might help. I'm going to show we're multiplying it by each term. The p plus 3 and the p plus 3 cancel. I have 3 times p minus 5 plus So the p minus 5 and the p minus 5 are going to cancel. This is p plus 3 times p minus 4 equals, and then if it's 6 times p plus 3 times p minus 5 divided by p minus 5, this is 6 times p plus 3. All right, so now I no longer have the variable in the denominator. I can distribute. 3 times p is 3p. 3 times the 5 is going to be 15, so I'm taking away 15, plus p squared minus 4p plus 3p minus 12 equals 6p plus 18. P squared minus p, oh sorry, not minus p. 6 squared, 3p take away 4p is negative 1p. Negative 1p plus 3p is going to be 2p. And negative 15 minus 12 is, we're taking away 27 equals 6p plus 18. So I'm going to subtract 6p. I'm going to take away 18 on both sides of the equation. So p squared minus 4p minus 45 is equal to 0. I got p plus some number and p minus some number. So looking for two numbers that multiply to negative 45 that have a sum of negative 4. That should be a positive 5 and negative 9. So again, we're almost done. I need to set p plus 5 equal to 0 to get p equals negative 5. P minus 9 equals 0. Add 9 to get p equals 9. All right, so that's going to be it for what we're covering on the test. Email me if you have any questions, and good luck.